Hi, welcome to ForNetPy videos. This is DC here. In this video, I'm going to show you how to use the access rights feature of Atmel AT88SC153 secure memory card. These are some of the highlights of the feature which we already covered in my previous videos. So we know that there are three user zones in this memory card, and there are two write passwords called password 0, password 1, and there are two read password, again password 0, password 1. There is separate access rights for each user zone. So since we have got three user zone, there will be three access rights, and each access rights control a specific user zone. The following things can be done using the access rights. We can set whether or not a password is required for read and write operation, whether or not authentication is required for read or write operation. Now the authentication is a second level of security. So you can have a card which is protected by the password and which is not protected by the authentication. If that authentication is also required, like you're going to have a double security, in the first step the user has to authenticate. Most of the time the authentication is between the reader and the card, and after that you're going to use the password. So there's a two levels of security if authentication is also enabled. So you can decide whether to use a password 0 or password 1. Now we have got two separate passwords we have seen here, and you can also make the user zone completely read only so that no write is possible. You can also allow the changes to the data only from the bit 1 to bit 0. We know that bit 1 is the erased state, or when you buy a new memory card, the memory bits are set to 1. You can allow users to change only from 1 to 0. This is very similar to a kind of a ticketing system, or called as a OTP in other contactless cards. It's called one-time programmable. So you can enable whether you want the user zone to behave like that. You can also enable locking for the first 8 bytes of each zone. So these are the things we are going to see and have a working or hands-on experience in the later part of my videos. If you look into the documentation of this memory card, you can see the access rights bytes are present in the configuration zone, and it is also inside the fabrication subzone. So these are the 3 bytes we'll be focusing now. All these 3 bytes are identical, so we're going to focus on just one of the access rights. And if you scroll down further, so there's a nice explanation on what these access rights bits are. Now this is an example of the access rights. If you look at here, the bit number 7 called WPE, it's called write password enable. So this bit controls whether or not a password is required before the write operation. Now the way the bit works is, by default it is 1, which means the write password or password authentication or password verification. I think we should use the word verification here rather than authentication. The password verification is not required when this bit is 1. When this bit is 0, it makes the password verification required during the write operation. Likewise, we have got the bit number 6 called RPE. This controls whether or not a password verification required for reading. Now this is again controlled by having either 1 or 0. So these bits are not one-time settable bits. You can change this anytime as long as the system or the card allows you to modify. And the next bit is the bit 5 is ATE. This controls whether you want to enable the authentication in addition to the password, so which is controlled by setting this to 0. And you can also have the bit number 4 has got AOW, which is called the authentication only for write. This is also an interesting feature. So you want a double security check before a write operation can take place. That can be controlled by this bit. Now again it is mentioned here, if the authentication enabled is true, okay, you need to authenticate before either for read or write operations. The next bit is the PWS, and this we know there are 2 passwords for read and 2 for the write. So this bit decides or controls whether to use the password 0 or whether to use password 1. So since there are 2 passwords, just one bit controls which one to use, whether password 0 or password 1. Say for example, if you have enabled the password required for the write operation, if this bit is set to 0, and here if the password PWS is set to 1, it means that zone, that particular zone requires a verification from password or write password 1. Likewise, if this is 0, so you have to verify with the write password 0. The next bit controls the lock mode. So there is a feature here where the first 8 bytes of each zone can be lockable. If you have come across the contactless cards like ultralight or any SRX cards, there is a feature where certain blocks can be locked from writing. Whereas here we know that each zone has got 64 bytes. The first 8 bytes can be protected from the write operation. So whether this protection is enabled or not is controlled by the WLM bit. So whether it's 0 if it's enabled or 1 if it's disabled. The next bit, this controls the modify forbidden. This controls whether the write is allowed. If this is set to 0, no write operation is allowed for the user zone. This basically makes the zone read only. The program only bit, so this controls whether the changes is allowed only from bit 1 to bit 0 and not otherwise. Most often there is a changing from bit 0 to bit 1 is called as an erase operation. If you have seen the earlier version of this memory card is 102, changing from 0 to 1 is a separate operation called the erase operation. So you can control whether or not to let a user change from 0 to 1. So this was the theory. Now you're going to say the working of all these feature, and this is very important to understand. You have to master this if you have to use this memory card in any of your software project. You can see here I've connected my AT88 reader writer. I'm going to read the entire tag. Now when you buy a new tag, probably this is the values of all the access rights bytes in the fabrication subzone. Now none of these bits are set. So what we have seen in my earlier videos is with this setting, so I can go to any zone. So I'll try say zone 0 and change the values. And say write. If you try to read again, you can see that we are able to write to zone 0 and same for zone 1 and zone 2, when the access rights values have got what you see here. So the reason we are able to write is because the bit 7 of all these access rights access registers is set to 1. So bit 7 controls whether the password verification is required before the write. Now none of this WPE bits is set for all the 3 zones, so that's the reason why we are able to write without any verification. Now I'm going to play a little bit with the passwords which you have seen in my previous videos. Now this is a new tag altogether, and I've changed the password to, now this is my secure code, and with this, once you verify with the secure code, and we are doing this because this card is still with only one fuse, the fabrication fuse blown, not the other two. So after authenticate with the secure code, you can see the passwords of all of the, or you can see the remaining passwords. Now you just have to make a note of these passwords. The write 0 has got all FFs, read 0 FFs, and I'm not going to change this thing. You just have to remember the passwords for write 0, write 1 is this, and read 0 and read 1 is this. So go back to the fabrication zone. The first thing I'm going to do is enable the write password, and as soon as you take the bit value changes here, enable the write password, and I'm also going to set it so that here, now this is the PWS bit. If you see the documentation, PWS tells you whether to use password 0 or password 1. I'm going to keep it at password 0, and I'm going to do the same thing for all the 3 user zones. Now you can have one of the zones set to use the password 1. So what I'm doing here at this moment of time is setting the write password enable for zone 0, also setting it to use the write password 0, that is this password, and for zone 1 I'm enabling the password verification before write and setting the password to 0 here again, and for write for zone 2 I'm setting this to 1. I'm going to write the value of AR1 and the value of AR2. Now what we have is all the 3 zones are now write protected by the passwords which I've set here. So I'm going to try to reset or reactivate. I'm going to try if I select again. So will it reactivate or repower the card? If you try to read, so this is the data I've got. I'm going to try to modify, say I can just do the last bytes, set this to A0 and A1. Right, now the write looks successful, but if you try to read, if you can see that this is the command we sent, the last 2 bytes A0 A1. If you try to read, now what we read was the old value. So what we just noticed is, this select card command. So that's the first command we send before we start accessing this secure memory card. It resets the card. So I remember reading this in the documentation of this ACR38U. So you don't have to remove the card and place it back. Now we just noticed that the free write access that was possible before, it's gone. So in order to write any of these zones, probably we'll try with the other zones as well. change this to the write and read. So this is also not possible. When you include this in your own software, so it's better that after you do the write operations, you do the read and verify that these 64 bytes or the bytes in your writing matches what you read. You don't have to click here the read. So I'm going to verify. I don't have to verify with the secure code. I'm going to verify using the write 0. So I know the password was all FFs. Verify. So when the verify is successful, you can read the value of the password. Read. Okay, I think the verify is not successful maybe. So I was wrong there. You cannot read, if you verified with the write password 0, because if you look at the documentation, is this row here, the passwords, if you look at this row, the read is possible only with the secure code, and it's not, probably you can read it only with the right password. Okay, so our tag is at FAB0 fuse blown. Now secure code is the right password 1, and for that reason we are not able to read it. So that's okay, just a learning thing. Now I have verified. I'm going to go to zone 0 again, try to modify the last 3 bytes, write successful, and say read, and the read is also successful. And if you remember what we did for zone 1, it's the same thing. So for zone 1 we have set, there's one interesting thing you'd observe here. Even for zone 1 we have set for password 0 the write password 0. Both zone 0, even zone 0 is set to write password 0, and zone 1 also set to write password 0. And you can think of this scenario as having one single zone and one bigger zone with 64 plus 64, 128 bytes. So this feature is explained in the documentation of this secure memory card. So by having all the 3 zones set to the same password, you are treating them as one single bigger zone. That's an interesting point to remember. Now I can go to zone 1 as well, and I can modify and write. So you're able to modify. If you try to do the same thing for zone 2, write. If you try to read, you can see here the write was not successful for zone 2 because the access rights was set to use the write password 1. So in order to write to zone 2, I have to go back and verify with the write password 1. Verify. So verify successful. So you can find out whether verify is successful or not by trying to read the value of the PAC. Now go back to zone 2. Write and say read. Oh, there's something wrong here. I know what went wrong, because I somehow verified with read 0. So I should have verified with the write 1 password. So I should have verified with this one. So I know this is still called as a secure code. I'm going to verify. Read is fine. So now write is C0, C1, C2, the write and read. Now read, you can see that it's possible. So that is how you control the write access for user zone 0, 1 and 2. So next I'm going to show how to set the read password. Go to the fabrication zone. I'm going to use, so first you have to verify with the secure code, which I think we are. Yeah, we are in the secure code verification. I'm going to change, also set the read password as well. So read password, you can set it to password, read password 0 or 1. I'm going to set it to 0. I'm going to do the same thing for the user zone 1 and user zone 2. I'm going to just keep whatever number it is set here. So it's write, write and write. Try to read, probably now it's still okay. So now even both read and write are protected by the password. I'm going to deactivate and reactivate by sending this select card command. If I try to read, probably the best thing is close and select again, reactivate. Now I've got nothing here. If I try to read the entire tag, look at that, this is populated with 06, and we have seen this hex value 06. So when I don't understand why we get 06 here, but what you have seen here is we are not able to read the value of user zone 0, 1 and 2. So in order to read, we have to first verify. So I know that I have to verify with the read password 0. It's over here. If I verify, and if you go back to user zone 0 and say read, now the read is successful. Go to, so the user zone 1 is also set to read password 0. I can read this zone as well, but if you try to read zone 2, you cannot, because the zone 2 is set to use read password 1. Go to read password 1 here, verify, and you have to keep in mind, once you change the password number, the card remembers only the latest password authentication. Even though you verified the read password 0 and then the read password 1, the card doesn't remember that read password 0 was verified. So it's always the last password that's verified the card remembers. Go to zone 2 and say read. So now we are able to read the zone 2. So I think that's all I would like to cover in this video. So this happens to be a part 1 of this access rights. The remaining features here I'll be covering in the part 2. Thanks for watching.